So as you can see here, these wheels have a layout. So as you can see, they have an X shape if you view them from the top. So let's go to our example. So example here, we have these parts here, and additionally we have this U channel here. So the length of U channel depends on what chassis you want to CAD, but in this example we're just going to go with 8 hole, like 1, 2, 3, 4, 5, 6, 7, 8. Let's go with 8 hole. So we import this part by, well, you can see here, we go to structure, channel, 1120 series, and then you can see there's 8 hole here. So we can do this exact same here. So we go back, 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 go into structure, channel, 1120 series, and you can see here that there is the 8 hole one here, and we can import it just like this. Boom. But we can basically we can save a little bit of the trouble by just importing the configurable version. So you go back, you can see here that there is the configurable version of it. So you can choose which hole you want. Boom. And then you can import it like this. So for to make this a little bit more clear, I'm just going to go to the front page. So you can see not the front view, like this is the front view, and this is the top-down view. To make it look a bit more similar to what's actually here in this example, I'm going to rotate this by 90 degrees, 90 degrees, and then the wheel, I'm going to drag it here, rotate another 90 degrees. So as you can see here, this wheel here, it has, the two sides are different. So you can see there is more space on this side than on this side, as you can see here. So according to this, if you look very closely, I think this is attached on the side where there is a bit more space, but I'm not the most sure about this, but let's just like attach it to this side. It could be this side too, but it doesn't really matter that much, essentially. So let's import the next part. So which is this shouldered hub shaft. So likewise to here, we can navigate manually into motion, shafts, because it's a shaft, it's hub shaft, right? It's a shaft. So hub shafts, and here it is. So one thing you can do with the library is that you can actually just search up the SKU number like this. Copy this, and then go back, insert, and then you can see here, we can just search it up in here. And then, whoops, why are these parts divided? This is weird. Search it again. So as you can see here, this bugs out quite a bit. So you normally don't copy in the SKU number directly, but I should be able to find a normal version of this, shouldn't I? But whatever. So you can see this method sometimes works and it sometimes doesn't work. So normally you just want to navigate directly if you know what you're doing, but like sometimes you can just still search it up. It's a bit more useful for like parts that aren't able to be divided into two parts like this one. I'm going to show you that later. So let's go to GoBuilda, motion, shafts, hub shafts, and here it is. You import this, and great. So as you can see here, there is this GoBuilda build ecosystem. So as you can see here, there are 16 by 16 millimeter pattern sets, and there is also a 24 by 24 millimeter pattern. GoBuilda keeps a 24 millimeter pattern, but normally we just use the 16 millimeter or 60 millimeter. So as you can see here on here, so these two are spaced 16 millimeters apart, and they form the 16 by 16 millimeter square. But also, additionally, you can form 16 by 16 pattern and a 24 by 24 pattern with like this kind of part with these like holes made out of two semicircles. So as you can see here, this is also 16 by 16 for the inner diameter of this these semicircles. But if you use the outside semicircle with the one diagonal to it, you can see it is, well, 24 centimeters. You can see it here. So this is a convenient part about the GoBuilda ecosystem. But let's just make this with the mechanical mill. So you can just press M and then click on one of these circles here. Then you go here, and then you can also click on another circle, this one. Okay, great. And this binded perfectly. So sometimes if it doesn't bind perfectly, you can also reorient the second axis like this to rotate it around, or you can flip the primary axis if it gets messed up like this. Additionally, you can do offsets. And for instance, you can rotate about X if it's not perfectly right, because normally for fasten made, you can only rotate by 90-degree increments. So for instance, you can rotate by 45 degrees by rotating about rotating about Z in this part. So yeah, but I'm not going to rotate because this fits perfectly. So great, so this works now. Let's go to the top front view again. So now, as you can see here, that there are these bearings. If you look very closely, you can see how these are installed. So you can see like the outer rim, the 15mm rim, is on the outside of the channel because basically this presses, the hub shaft presses against this bearing to keep it in place. And the same case here, you can see the 15mm outside is basically on the outside of the channel, and the screw is pressing it into place. So let's do that. Let's import a bearing. So insert, motion, and then you go to bearings. Oops, sorry. Go to bearings, ball bearings, flange ball bearings, and you can just import the Rex one. We always just use this one. So import this part, this assembly, and we can import another one because we need to use two in this case. So fun thing about these bearings is that there is a revolute mate inside them. So as you can see, these bearings are able to be rotated. Let's fasten this first and then show you that, because right now it's just moving. So we can do this, press M, and then select this face here that's extruding out. And then as you can see here, this bearing is mounted on the second hole. So we choose the second outer, so we choose the second hole here on the outside. Do not choose this one, choose this one. Okay, and then boom, it's done. So as you can see here, this is a small revolute mate. So you can actually just revolute this. Do you see? It revolutes. Actually, let me fix this real fast. But you can see you can revolute this. Pretty fun. Then we made the second bearing. So you choose this side. Okay, great. And then choose this. Choose this. You see, this is not the right way we want it to be, so we can flip the primary axis. Boom. Hooray. And now, let's fasten this to these bearings. So one annoying part is that you can never really perfectly assemble these hex shapes together, actually. It's pretty hard. So one thing is that you want to do is basically just assemble using the circle here. So for example, you can just do mate. You can choose like this. It's totally fine if you just choose an arc because it's still going to be the center of the circle of the shaft here. And then you just press it against, let's choose this one. Because you can see the bearing is made out of two parts. So one, this is like the inner part here, and there's the outer part. So the inner part can spin freely. So we can choose, for example, this here, press shift, and then we can move to a circle, or we can choose the outer diameter, the smaller outer diameter of the inside moving part, like this. And as you can see, this the circle presses against, I mean, like this round part presses against this bearing, so which limits the bearing from moving out. Great. So you'll say, hey, this bearing can still slide out that way, but don't ignore the fact that we're also gonna fasten in this side. So after we fasten in this side, the this shaft cannot move in either way, and it's fully constrained. So we don't really need to actually make this because this is actually constrained already. So sometimes making it will introduce some bugs, but it's probably actually isn't in this case. But as you can see, like these two parts, they're not 100% perfectly aligned, and this causes some small issues. Oh wait, as you can see here, this is a flange ball bearing with an 8mm bore, and this is one with a 6mm bore. So we actually need to edit this. We actually cannot use the 8mm Rex one. So this is why it's pretty important to read. I'm blind, so sorry about that, guys. So let's delete these